I originally was in the entertainment industry, and coming from the entertainment industry and also with an interest in science, I found myself asking, what else could I do? What else could I do in the world of like being creative? What could I do in the world of trying to contribute to basically trying to help make the world a better place? And I love technology. Do you see the slide that says Andrew Mayne up there?
Yes, we do see the
Cool.
slides.
I realized I had two versions of Google Slides open here, so I was giving another slide demo for who knows. So again, my background is before I got into AI, I did some other things. I write novels. I'm still a novelist. I still like to do that. I like to sort of exercise kind of all sorts of sides of my brain, from coding to writing. I think that's helpful. I also had a TV series on the A&E network in the United States, which aired elsewhere like Discovery. It was called Don't Trust Andrew Mayne, but I assure you, you can trust me, everybody. I'm totally trustworthy. But my interest in AI really got sparked when I agreed to do a stunt, which was to try to fool great white sharks. Because as a background as a magician, and I performed for years on stage, and I created magic for people like David Blaine and Penn and Teller, and worked with David Copperfield, I always wondered, like, hey, could you fool a shark? Could you fool a great white shark? Would some of what I understood about how magic worked apply to something like a great white shark? And it was more of a theoretical question for me, but then I made the mistake of talking to that about with some executives at the Discovery Channel who do Shark Week, which is a pretty big thing here in the US, where 1 week a year they have all these different TV specials where people go find out interesting things about sharks. And I'm like, I wonder if I could fool a shark by trying to make myself invisible. And so in doing that, I started to study how sharks perceive the world. We talk about how sharks have an incredible sense of smell, their ability to smell like blood in the water. They have a sense of vibrations. They can pick that up. They can pick up electrical fields. A lot of different sensory data going in there that make them, the most amazing creature, I think, that swims through the ocean. And they also have incredible vision. They may, like great whites, may see more into the infrared than we do. They may have color vision. They see things extremely well. But all that data going to that small shark brain, which is a very efficient brain, means that there has to be some sort of algorithm to sort of throw out what's not essential. And at the time I was doing this, I was also getting into studying how to do image recognition, and because I wanted to build a device that when I was underwater would give me 360-degree vision. And in doing that, I said it'd be great if it kept track of objects. And that's why I started discovering things like OpenCV and all these libraries for image detection. And while working on that, I was talking to the shark scientists, and they said, if you're in a shark cage, the shark doesn't see you in the cage, they see the outline of the cage. And that made me think. That was an interesting observation. I'm like, they see the outline of the cage, but not that. Because in AI, when you read about, different vision algorithms, one of them is like HAR-like features, the idea of like the shape of pixels instead of trying to look for details within there, trying to figure things around it. I'm like, man, that sounds a lot like that. And the more I studied, the more I realized, they're using algorithms. So to make a long story short, I figured out that maybe I didn't need to worry about my specific pattern as much as the contrast ratio. If I could blend into the water. And so I built the suit, which you see there on the right, which basically what it was the material on it had a property where you could make it illuminated, and it could basically try to blend into the background. So for the baseline, you see on the left, I went down there with great white sharks and just myself and a cameraman, Andy Casagrande, who's done a number of wonderful shark specials. He's an amazing diver and cinematographer. He shot me first. He was in the back of the submersible, and then I would go out there, and I had like a shield, which was actually like a garbage can lid or something we got in an office or a hardware supply store in Australia. So I went out there, and did the sharks want to come up to me? And there were about 16 great whites at that time, and sure enough, they thought I was interesting. And the way great whites are is they'll go up to you and see how close they can get and maybe bump you. They can see where you're looking. They can absolutely see where you're looking. And to practice that, by the way, I made a little VR game using the A-Frame library where I had sharks that would swim around me in virtual reality. And then when I wasn't paying attention, try to sneak up on me. So that was to keep me on my toes, constantly turning around and trying to say, hey, I see you. And if a shark comes at you and you turn around and you look at it, the great whites would go, oh, I'll just go this way. They'll just veer away. So first we did it without the suit, and the sharks came up and would bump into me and would circle around to try to get close. When we did the suit, turned it on, I didn't know what was going to happen. The sharks scattered. They stayed away. I don't know if it's because the theory was right or they're just like, this guy is too much of a weirdo to get close to or whatever. I don't know if I looked invisible or like a black hole or was just like not worth the bother, but it was a very interesting experience. But seeing that relationship between how they processed information and how image systems work got me really interested in artificial intelligence. So, and that led me to OpenAI. And what does OpenAI do? Like I said, we're working towards trying to develop systems that can help make the world a better place. And that means taking a lot of different approaches. You may have heard about GPT-3, and we're certainly here to talk about Codex. Our newest system, which we just launched last week, is DALL-E and DALL-E 2. We had DALL-E before, and DALL-E 2 is an improvement over DALL-E. And it's been amazing to see the reaction to that. And there's a video which we can check out, or if you want to check out, I highly recommend go to our website and you can see that. Let me just go see if I can share with you the website for that. And I want to explain a little bit about that and why that plays an important part with Codex and GPT-2 and GPT-3 and where we're going with that. So let me just stop that. And then we're going to switch here. Pardon me, I'm just trying to manage all of my windows here. This presentation, unfortunately, I can't confine it to just one. There we go. And let's see if that worked. There we go. So DALL-E 2, basically what DALL-E 2 does is it's an improvement upon a method to try to generate images. And if you read the paper, kind of technically what it does is it takes a text input, like, I want a picture of a pony in a meadow with a comet flying overhead. And it tries to get, and I love the word gestalt, the gestalt of it, say like, what is pony about an image? What is meadow like about this? What is this? What things make this like that? And it tries to extract that from there. Instead of just going literally from text to image, it has a sort of intermediary layer where it tries to understand what somebody's trying to do. Not unlike an artist, which is, you look at something and say, okay, what makes this color feel like this might be, a pattern or something I want to use? What makes this shape remind me of something else? So we came up with a bunch of different examples here, which you can try just to sort of see if you change this to teddy bears, mixing sparkling chemicals, or working on new AI research. And you can see it can do different sorts of style of art, etc. It is incredible the number of different things it can do. And playing with this is extremely fun. So I highly recommend you go sign up for a wait list here, by the way. And we're going to try to roll out access as we're able to. But you can see it can do things like this. Basically, generate all kinds of different images. You can make a bowl of soup like it's a portal to another dimension, make it look like a scary monster, and you can make it out of different materials. And these are just text things. We didn't program these things in specifically. It's just a thing that it learned by learning from images and text. And we have a video that kind of goes into greater detail a little bit about that. You can edit an image. You can go in there and select a region and say, I want you to add things, like add a pink flamingo. So you can take an existing image and add it. You can also do variations. You can give it an image and say, hey, make variations. So it took this classic painting, and then it said, okay, I'm going to make this version, and I can do this version. I can do that version. And it is startling because I've seen us do this where I'm not as sophisticated as I should be with art. And I look at some of these and I go like, I don't know what the original was. I don't remember what that was. So, and we see it with different styles. We can do this like here. We can do the picnic with just a different sort of look to it. And that was really one of the things that impressed me the most personally, was the fact that it was able to capture that idea, or sort of, basically what made that sort of special in its own way. And it's also as a tool for an artist to think about the idea that this is how you collaborate. Michelangelo or Leonardo da Vinci did not work alone. He had a studio of other people to help him do things, from preparing his canvases, his paints, to make things work. He still had to be the instigator with the idea. He still had to be the person to say, this is important. This is why we need to capture that. And that still exists. No matter what kind of tools we make that are assistive to people to help them create imagery, it still needs humans to drive it. It still needs people to say, this is important and this has meaning. And when you generate one of these images, it will create like maybe 10 alternative versions of them. Some of them are good, some are not, and it's up to you to sort of figure out what you like. So we have a video here that goes into it and some more examples. This is sort of showing the improvement from the original DALL-E to DALL-E 2. And you see a very, very, very big, that's clearly Claude Monet sort of style there. And this talks about some of the data on that. So by all means, have a take a look there and see that. And you read through the paper too, watch the video, and you also get an idea of what are our concerns. We're doing these things slowly. We release these things in stages because we want to make sure that the positive impact, it's a net positive impact. And that means doing things in small research settings, scaling out to more people, seeing what the response is, how it's used, how we can protect against misuse, et cetera, and then moving forward from there. So that's just an update on DALL-E. But we're here to talk about Codex, and I could do later on if we have time. If you want a DALL-E demo, we can do a DALL-E demo. But let's dive into Codex. And Codex has been just one of these things where watching this develop, watching this thing happen from inside, seeing it go from sort of just this idea to like, hey, can we take what we use with GPT-3 and can we apply it to that? So let me just pop on over to the other slide share here. Okay, and my control. Oh, sorry. All right, I'm gonna give you a little background on this using just some explanation a bit about how GPT-3 works, because we'll kind of give you sort of an underlying thing there, and we'll try to go through that pretty quickly. So GPT-3 is a system that tries to make predictions about text. You give it some text input, and it tries to make an output. And this is the same with Codex. And when we talk about making a prediction of text, you start off with something like this, okay? This is basically how text gets tokenized. When it gets tokenized, it takes a string of text and it says, okay, instead of saying the word the, I'm going to use 2221. Instead of the word a, I'll use this. Instead of the phrase this is, it might use longer things, or it might break something down. It might take a longer phrase like, telescope, and I might say, okay, I'm just going to use this word. I'm going to break it down into a token for tele and a token for scope. So the relationship between tokens and words isn't one-to-one. It depends, it varies. And we used a tokenizer for GPT-3. We actually use a different method for tokenizing for Codex because code has its own sort of vocabulary with different frequencies, et cetera. So this is the way these models, but they all at one level, they convert stuff into these numbers. And a prompt is what we use for GPT-3 to make a prediction, and the same in Codex. Codex, basically, you say, it looks at one thing and tries to predict what comes next. And I'll get into where that came from in a second. And we didn't program GPT-3 to do anything specifically. When you see it do these things like it's functioning like a chat bot, or it's doing TLDRs or classifications or summarization, it learned all those things purely through reading text, purely through just reading text and trying to make predictions and testing itself and improving over time. And that's one of the amazing things about these transformers. That's the underlying technology behind these big models now, is its ability to learn and pick up stuff. And then GPT-3 was a big bet for us because we did GPT-2, which proved, hey, transformer technology can do pretty good text completions. It can make stuff, little short sentences and stuff that feel very real and coherent. GPT-3 was an effort, and let's scale this up. Let's scale this up much, much larger than we did before, up to 175 billion parameters and see what happens. And that proved that you could scale these things up with a lot more data, a lot more parameters, and those models got smarter, measurably, objectively smarter. And that wasn't known. That wasn't sure. There was a thought that there would be this sort of this cliff. You couldn't improve upon that. There are some people who kind of made very, pronounced statements like, after GPT-2, yeah, but these models won't be able to do blank. Well, GPT-3 came out and it did that. But it's not AGI. It's not, it's not a sentient intelligent system like the type we're trying to build. And it may not be the path towards there, but it's interesting and it does useful work. When you control things, and whether it's Codex or GPT-3, we have a thing called temperature. And when you think about the world of possibility, when you give it some text, it can take a very linear path straight through and just say, okay, I'm going to do the thing with only the highest probability and kind of make my way there. Or you can say, if something kind of fits, if you said, I put blank on my feet, probably answer is shoes or socks. That's the high probability answer is shoes or socks. But maybe peanut butter. Maybe in some rare instances, you might put peanut butter. And so when you set your temperature higher, it says, well, maybe I'm going to do the crazier answer, which could happen. And that's, a way to think about that. Some people describe it as creativity. I think it more as kind of randomness, but randomness that still might conform because it's trying to predict what comes here and what comes next. And in models like GPT-3 and Codex, a way to think about how they're sort of different than what came before was with transformers is they don't just try to predict the next word. They look at a sequence and they try to predict things that might come in between some other word further down the line. They try to predict strings, and that makes them smarter. Instead of saying, well, only this word comes next, this word that comes next, they can plan ahead. So low is good for classification. Medium, there's a high probability. There's one right answer, but it can be phrased differently. High, consider any possibility. And code is pretty deterministic. So you can kind of play kind of in the lower sort of regions and it's pretty good. But if you're trying to get Codex to do something a little bit more, maybe not quite, give it the opportunity to try something different, you might play with your temperature a lot. I don't play with temperature as much in Codex as I did with GPT-3 because it's a little bit more, like I said, deterministic, okay? So let's talk about Codex, exploring Codex. It's a language model that understands programming languages and code. Now, what do we mean by that, okay? Well, when we break apart, basically, when you look at anything that you write or look at GitHub, you see that this is the instructions, this is the way that we tell a computer to perform an instruction. In this case, we're telling it, to do a while loop, right? And while x less than 0, do this, dot, 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 okay? Now, if we go and we look at what actually is what we write, we'll see that we have comments. This function counts to 100, okay? And so we tell it in our little, basically for ourselves, when we go back and later on and look at our code to figure out what it's doing, if we're good coders, then we write functions with or statements and stuff that have comments that explain what we're doing, because our goal is for us to understand later on and other people that have to look at our code. Because those instructions are there and we have models, we have these transformers that can go on there and can read things like this comment and then see what comes next. It can learn from the comments what the code does, as well as learn this code. If you have x equals 0 and while x is less than 0, maybe you're going to want to do this task like, add 1 or whatever and print it out. So that's what's kind of neat, is that you can take the same thing that was used to complete text in articles and blog posts or whatever else you want to write, and you can also apply it to code because that little data there is very helpful. And I'm going to give you some examples a little bit of coding entirely through writing comments. You can write comments, but Codex can write from comments. It can also just complete the code here. It can see what's missing in the middle, etc. Like I said before, it's all tokens, so it's going to be breaking all that down to figure out what comes next, okay? And when you have a system that understands natural language and can code, it's magical, and its ability to predict is just, it's a whole other level. And it's just, from a functional point of view. Okay, and so what it does here, like this is just an example. If I write, define, create Stripe customer email like that, it's got a pretty good idea because it's been trained on so much code. I probably want to do something like this, is actually create a person and it knows things about Stripe tokens and maybe the sources or quest form, etc. That's what's really cool and kind of spooky about Codex, is that it has a very good understanding of a lot of things that came before. It's learned a lot about libraries too, okay? So when you make a comment, it makes a prediction. I could just go here, I create a new Stripe customer from an email address, and if it knows what language I'm in, presumably because I'm using that environment, it's going to add that together and say, okay, I'm going to create this based upon that. And you can also say, hey, I have a function. Now down here, function 1 is used to, and it will go in and finish and explain it. It will actually help you understand what it was doing. So you can go into code and say, hey, insert a comment here that tells me what this function does. And it's pretty good at looking at all those other functions and figuring out like, oh, this took this part from here, this took this part from here, and I think that's what we're trying to do, okay? And it's also can be multilingual. So I believe this is Japanese, and we was able to take Japanese and basically create the same thing. It took that, was able to understand that. So that was pretty fun. So this is out of date. Codex has improved upon this. I need to improve this already. But like at the time, it could comprehend 25 different programming languages. It understands probably many, many more now. And it's got a lot of these different capabilities. Libraries, like its ability to understand libraries is fun and useful. I have libraries I use for certain functions that I did not know existed until I gave Codex a task. I'm like, oh, I got to extract a bunch of transcripts from YouTube. And then it says, oh, well, here's this Python library that literally will go grab the transcript from the file, from the YouTube video. I'm like, really? Tried it and it worked. And there's a lot of things like that where you can find things out. Always check the library first. Always go to the page or the source to make sure that it's something authentic and something you should be using. But it is pretty cool to be able to see that. Okay. You can do some really clever stuff too. Like you can check things like check the log probs, or basically you could if you want to have an output and make sure that it best fits it, there's a lot of little cool tricks you can do to sort of improve the overall output quality of it. Okay. It understands some languages better than others. It's really good at Python. Works pretty well at low temperatures. You can go higher. And professionally written comments, that is if you use things like doc strings, work really well. Doc strings work better than just sort of like inline comments. And that might just be from the quality of stuff that it observed, whatever. But if you're trying to give it a lot of tasks, and also doc strings are finite. If I start it and I say, here's your instructions, and then I close it, it then knows it needs to write code and not just write more comments, because it will write more comments. It will, if it feels, oh, that's more appropriate here. Okay. When you're using a playground environment, whatever special, be sure to specify what model you want to use. So let's stop sharing for right now, and we'll jump into the next section. Hello. All right. So we want to try some demos and some examples with Codex. And also, by the way, questions are very welcome to happen in the middle of the conversation, and we can also have questions at the end. So I'm not sure how we take questions here, but if anything pops up, whatever, I'm very happy to address that. But let me get the next demo ready.
Just while you get ready for the next demo, all of the questions, you can write them in our Slack channel. That is channel number 3. And I will read them out for you.
Fantastic. All right. So we don't have any right now. I will jump into our little environment for doing some code. Which window am I sharing? Actually, yeah, this is fine. So this is the playground environment. This is one environment where you can play with Codex and you can try different things. And I have this engine set, the Code Da Vinci, which is basically our latest model for doing that. And we can try some different things with it here. So right now it's set up like we have this example of, let me refresh that. We have this, create a JavaScript dictionary of 5 countries and capitals. So let's go ahead and do that. Let's say create. Nice thing is it understands misspellings most of the time. And by using, enclosing it like this, as opposed to using, let's say, the forward slashes, it tells it like, hey, we're done, so don't keep writing comments. So I'll set that temperature a little bit higher there. And I'm gonna set, you have your maximum length as the number of tokens that it can start to produce. And I'm gonna leave that at like 256. If I want, I can put a stop sequence where I can tell it when it gets to like, when it wants to create a new comment or something, but we'll just do that. So we'll click submit, and you can see that it's starting to actually just create a list like this, created a dictionary, because it asked for a dictionary, not an array. And if I wanted to keep it from doing this, notice it's trying to be overly eager to help out, I can just say, okay, I'm going to put this into my stop sequence. So when it comes to there, so we created a dictionary of 5 countries. Okay, now if we created a array of 5 countries, and I'll go back there and leave it like that. Let's see what happens. We'll back up so I don't have it repeat that space. And we get a list of 5 countries, just like that. And it's kind of using its GPT-3 sort of, smarts, because it knows what countries are, but it was able to take those and just output those like that. Now you can scale up and start to do more interesting things. You can do things with our other interface here, which is really fun to play with, which is our sandbox, okay? Because sometimes you want to play with code and see what it does. It can do a lot of different things. But if we, by the way, we'll just go here and we'll do, we'll say Python. Let's do let's say YouTube video transcript. Let's say I want to build something and I don't quite know all the parts I need. It's always the best way to start building something. I could just say something like that, and then I could just let it run and see what it decides to start adding. If it could see what libraries it says, okay? Got a beautiful soup, we know that. Now here it's asking for a lot of different libraries, which maybe they're essential, maybe it thinks it just needs to get these. But I can see like, oh, there's a thing called YouTube DL, etc. And I might say that that's pretty cool, right? I might decide like, okay, probably I only need these things here, and then I could just start def and just tell it like, okay, let's go ahead with a function. And then it starts, can give you some input on what I need to do. So if you just sort of don't even know where you want to start, you can use things like this and just give it an input, but you can say like, what library do I use to get something? And I might say, oh, use YouTube DL, which is a thing to download. It's a really neat way to sort of be very lazy and search for things. But when you really know what you're doing, it's even more powerful. So let's go over here and we'll try our little JavaScript sandbox. And what this does is it basically will take instructions here as comments, and then you'll see the output over on the right section here, and then it will display in there. And so we have some examples, by the way, and these were literally like, I'll copy this. These were literally just things that were thought up like in the middle of the night, like, oh, I need to put some things in here. So if we ask it to, we give it a URL, display an image of a cat, and hopefully that URL still works. We tell it that. Codex is going to take this, and you can see it's already generating the code for this, and it added that image of the cat. It knew to say, okay, take that, create that there. But let's make it smaller. So let's make it 20%. And we'll see if it takes that instruction, and boom, it just reduced it, okay? And we could do things like add a caption that says, meow. And there we go. Now it says meow. Impressive. Right? Well, I mean, it's a simple demo, but point is you can keep scaling up there. You can start doing bigger and better things. This was something that was sort of fun, was just kind of randomly. I typed this in just to see, like, I wonder if it will do this. And get rid of the window there, and let's clear this, clear everything. I just typed in make a snowstorm on a black background. I was curious, what would it do? Would it understand what I meant by that? Had somebody already written something like that it had an idea of what it was, supposed to be doing? And sure enough, I watched it start to create these functions and start to do this. And when it finishes here and runs, we got, well, that's like one thing of snowfall, but we can go ahead and try this again and see if it does it differently. And that's the thing, when you have your temperature set higher, it will try to solve that problem different ways. And that's one of the really cool things about it. It will try to solve these things from different approaches, and it will try to figure out a different way to do it. It may do the exact same thing before, because I think on our newer image, our new model that we're using for it, it may have changed things up again, but we'll try that demo one more time to see if it does it differently. And nope, does it the same way. So we'll try, let's try create a random dice roll. So I asked it for, let me clear this before we add it all together. So we asked it for create a random dice roll generator with a button, and it's still processing the last thing I did because I forgot. So let's just go ahead and redo this. Okay, create a random dice roll generator with a button. I didn't give it a lot of instructions. I'm like, I hope you know what a dice roll is. I hope it knows what a button is, and let's see if it does it. So let's see if it creates an output. And it wants to do an alert here, but let's try this. It may be blocking the roll. Let's try this again with create a random dice roll generator, the button, and display it. Okay, let's try that. There we go. So there it is, our random dice roll. So you can give it specific instructions. In that case, I didn't tell it what to do. And so as the model improves, it gets better, being more precise. So the first time I tried that, I'm like, create a button. And it had the logic, it was doing it, but it just wasn't displaying it. I needed to tell it, hey, place it somewhere. And that's the thing to think about is, I'm going to show you some examples of taking this to sort of the next level. And one of the things, that I learned through them is that you need to break it. It is really good at pseudocode. It has become really, really good at pseudocode. So you can give it basic instructions, but you still need to tell it what you want it to do. If you're like, make a game like checkers, you need to tell it the rules of checkers. You need to tell it what it means to do this and how things should move around, etc. You don't have to be that explicit in the language of how you're telling it to do, but you do want to give it enough instructions to do that. We have other examples here. Let's see if this one works with this one. Like you can create a simple calculator, and let's clear all. Like it's neat to see what happens when you just give it an instruction. How does it try to solve that problem? And I told it to create a calculator with an input, and let's see what it's doing, how it's trying to solve this one. So it says, I'm gonna add 5 plus 3 and 8. Congratulations, we made a calculator. But you think how cool it is. It figured out, okay, a calculator, I've got to do 2 things with numbers. And I could go in there and tell it, like, add a multiplicative function, add a divisor, add these things. But it just took that simple instruction. We just said, make a calculator, and it made a calculator. Granted, it's not the most sophisticated calculator, but we didn't tell it to make it sophisticated. We just said, make us a calculator, and it made a calculator. And that's kind of where things just get started. That's just the beginning. Codex isn't even a year old. Let's say, make a red ball dance around the screen. Let's clear all. Let's see if this works with this model. Its ability now to understand other libraries like I think anime.js and some other ones. It's really surprising. I've used those to create some cool demos, and I'll show you some examples of that in just a moment. But here, just in pure JavaScript, telling it to do that, it's create a red ball that is starting to, let's see, does it bounce around the screen or does it go off? Is it going to go off? Is it going to go off? Is it going to bounce? There we go. So we got a red ball that now bounces around a screen, and all we gave it was that little instruction, make your red ball bounce around the screen. I can add other balls. I can create interactions between them. We have a great demo done by Greg Brockman, who's one of our key people at OpenAI, where he creates a space shooter game. And that inspired me to try to see what else could you do with this model as these models improved. So let me do one more example here, which is sort of my favorite one, which was given a lot of instructions, which is just make a website for a cat that's an attorney, provide a bio and phone number, create a small round avatar image, and use that image. And I said, center everything. Let's see if it works with this model. And we see it creating the code, looks competent. And we're getting, it seems to be into a little local maxima there as far as what it's trying to say. So let's try. It keeps doing that. All right. This would be, if we were using a different environment, I would set the temperature lower. So let's go ahead and try this again. It's really very proud of the fact that it's a cat attorney. So let's try this again. Yeah, it keeps wanting to do that. So let's go ahead and do this. I need to be specific here in this case and tell it. We'll give it some text. Text is. I mean, it's funny when you let it write it, because sometimes it'll do things like, oh, I'll work for fish, or no mice. Yeah, this prompt just seems right now to just want to keep doing that. So we'll just go ahead and stop that. We'll try one more example here. As we adjust the models, things that are worked one way, other way, or here in our playground, we just have a fixed temperature. And I think for those prompts, I probably just need to adjust the temperature so that it's not doing that. But let's go to some different examples that are using sort of the latest, greatest model. I was super curious to see, as we improved the model, to see how capable it became with natural language, and using our latest model that is available for people who are experimenting with their environment, which is basically kind of like a Da Vinci model that does code. I thought, man, Codex was pretty good at natural language. Has this improved with natural language? Has this gotten better with natural language? And I thought it would be neat to try an experiment. And this was the experiment I wanted to try. could I make games and applications that were kind of interesting or somewhat useful entirely through natural language, never writing a single line of code, not splicing bits of code back in and together, literally just going through and saying, okay, build a box, print this here, do this here, and actually in one basically zero shot, give it the instructions at the head of the document to say, this is what you're doing for the rest. Not like you saw in the sandbox where I do a thing that I tell an instruction, literally give it a list of instructions, say do this. And this was interesting to me because if we want to get to a point where we're able to create applications and solve problems with code, we want to just say, go do this thing and then come back to me when it works, and I'm going to go move on and do something important with it. So to try this, that was sort of the basically what I decided that I needed to do was to figure that out. I built myself a little environment, a little coding environment, which was kind of like the sandbox, which I'll show you. Share my screen here. The sandbox was neat, but I wanted something that had a bit more control. As you saw the last example where it's kept repeating itself, it's like, oh, I need to adjust the temperature. So I just built my own little tool for this, and really it is not that complicated because under the hood, what it is, it's taking this text, it's taking the number of tokens I want and taking the temperature, and it's going to output it here, and then I can run it. So I could say, add a button that says hello when you press it. Okay. And a really high level programming we're doing here, folks. So I don't need that many tokens. I'm just going to say 200. So I'm going to send this to the model, and behind the scenes, I can see that it's sending it up to there to get a response, and you see how quickly it came back. So let's run this. And we need to add the button to the screen. So let's say, add a button to the body. Do this again. There we go. And now when I pop that, I don't know if you saw the alert, but the alert just popped up and said hello. If the alert doesn't show in the window, take my word on it, it worked, folks. It worked wonderfully. It was amazing. The most magical thing I've ever seen. But anyhow, you see, we can just give it some simple instructions. So all I'm doing is basically telling it here, this is going to be the comment. And so I wanted to use this tool to see, could I build more complicated applications? Could I just say, okay, if I've got a button and I say hello when I press it, it says, what I want it to do, and keep adding things to those instructions, wiping out the code it generated before, and then keep adding and trying to find the way to tell it to do what I want to do. So I'm going to show you the examples I was able to come up with it, and I'm going to tell you first. Some were very fast. Some happened very, very, very quickly. Some did not. Some of these things took me a long time to figure out the right phrasing for it. But here's the thing. Very few of them, if any, would have worked with the first version of Codex we came up with. Less than a year later, the improvement from natural language to creating things improved dramatically. And now we know a lot more about how to train these things and how to build these things. Things are accelerating. So I'm going to give you an example of where we are right now. And I put together a blog post, which was basically about building games and apps entirely through natural language. Here's a GIF of some of the things I was able to make, okay? So first up I decided to do was, could I make a game kind of like Legend of Zelda? And so I created what I called Minimal Legend of Zelda, which is basically you're a white square and you move around and you try to collect these gold pieces, these yellow pieces, and avoid the red square as it comes after you. That to me was like the most minimal version of kind of a basically like a little adventure game, was using that. I'm going around an environment. I can't go through the trees. I have to go around those green trees, and I have to avoid an enemy, and I have to collect gold. And also I get points. The other thing I said was, I want the screen to change each time you moved off screen. And I needed to have a randomizer to do that. And so it took me a while to figure it out, but these were the instructions. I was able to do it, okay? The big breakthrough for me was this newer model really understood arrays. And arrays are really important when you want to do things like game design, for a lot of forms of game design, because an array of arrays can define a game space. If you look at, let's say, if you wanted to build, Super Mario, Super Mario has all these tiles, and you tile going across, going across, going across to define that space. And if you have a system that can understand tiles, and tiles are basically something you can just an array of arrays, then you can do some cool stuff. So I decided first thing I wanted to do is create a tile map generator. And I said, one tile map generator, create empty space for 0, T for tree, G for gold coin, and then create a function that generates an array describing a 20 by 20 seed with scattered trees and 5 gold coins. Okay, that was my first instruction that I gave it. And then we'll actually try this to see how much of it works here. And I don't know if this model backend has changed on me. So I will make no promises, but I will show you the CodePen final version of this to be sure, but just as a fun experiment, let's go ahead and send this to here. And we're going to let it get the generation and see it create a tile generator in real time. And we can see generate scene. And so basically you can see the scene, that's when I talked about an array, and it has the array of arrays, and it's going to push things, and then it's using the math random to decide, is it going to be a tree? Is it going to be gold? And the default would be, I guess, 0. So you can see right there, it went through there and it's able to generate that. Now, if I had my console open and you could see it, I could actually output that and you could see the scene generator work. So that was the first step, was to make that background, basically create an array that could then be interpreted into doing this. Now, something I realized when I was working at this, if I said create an array that describes a scene, I wouldn't be able to reuse it. It would be happen once, but I need to create a reusable function. So when you work with Codex, you're trying to work on really long things, use reusable functions instead of just say this. If I said create an array like this, cool, it could do that. It could probably create, it's got a really good sense of numbers and build it in there. But what's better is if I say build an array that has this, then I can go call that later on down there when, let's say, I want to redraw the scene and I want to do something again. So in my advice about how to use this, which I have some tips at the bottom of the post, I talk about think everything in functions, think in functions, unless you have specific hardwired information you need, and I'll show you an example next for that. So that was the first step of that, was to be able to tell it to do this. Then I added the canvas to the screen. I wrote it, said just add a text display, add a map, add these things. These were the instructions. This is it. This is it. This is everything that was used to create this. And so if I pop open CodePen here, this is the thing that it generated, okay? And that was all of the instructions from here. Again, that's all it took. Literally, there was just like the craziest loud car horn in the background. So here we are with the game. This is what it created. I can control my character. Look, let's get some gold. Okay, I got gold. You can see the coins are in the lower left screen. If I go off screen, now I'm in a new one. Creating the enemy was fun because I'll show you the code for that again. I had to try a few different things. First thing I did is I gave it an instruction and said, create an enemy that tries to attack the player. And first time it outputted that code, I ran it and the thing went just shot straight towards me. You can build enemies that track you by sort of stalking you. And if it hits you, by the way, it takes away one of your gold coins. So that's that right there, okay? All I added here was this code. The only code I wrote for this entire thing was just some CSS to make this black and centered here. But if I get rid of the code, it still will work. It just looks like it's on a white canvas. That's it. That's all. I didn't write a single line of that. Did not write a single line of it. I never patched anything, never did anything. I tried several things. And if I couldn't get something to work, then I gave it up. And I talk about some of the things I tried to do, but I just couldn't get to work. That was all we had to do to add a monster. Add a red monster. It moves each time the player moves. It tries to get the player. If it touches the player, it takes away a point. It will try writing this several different ways. And so sometimes it that monster just sort of is kind of just very caffeinated and jumping around a lot. Other times it'll go boom, boom, boom every time you move. So I don't know if it followed that rule explicitly, but still it worked really well. So I talk about examples there. So I'm like, okay, cool. We're able to make a pretty basic game, but a game where you move around. There are rules. It will not go through trees. And I literally, just by telling it, add the player, stop the player or for the square from moving when it tries to move through a tree. It understood that and prevented me from doing that by keeping track of the game state. So I'm like, okay, cool. But it's probably seen a lot of RPG games. It's seen a lot of these games like this. It learned a lot from those games, and it may have just been reusing code. I thought, what if I try a game it's never seen before? What if I try a game that came out after the code model had been trained? And there's a certain 5-letter word game you may have heard about. And I thought, what if I tried to build that? knowing that it doesn't really know what it is, and build a simplified version of it. I didn't want to try to build the full-on version of Wordle, but I said I'll do that. And so I had to figure out how to do this. The first step is I needed to create a library of words. Codex is not GPT-3. So Codex, if you ask it for a bunch of words, it'll give you a few words. So what I did was I just basically went into GPT-3 and said, give me a list of 5-letter words. And then I went over here and I did that. So the first instruction I said was secret word. Create a function to generate a secret word. Again, I want to be able to reuse this. I want to be able to reuse this and not just say select a word. And then I do add things like print it to the console to test it out. Letter inputs, create 5 input boxes, and I had to get a little bit specific to try to make it fit. If I just wanted to use sort of ugly input boxes, I didn't need to be that specific, but I wanted it to have like the rounded edges and stuff. So I did that, and it took me a couple tries to figure out the right instructions, and I did that. And I'm like, okay, I got to keep track of the state, so I got to give each one an ID, which is kind of like programming. I mean, also, like if you didn't know how to program and you tried to do this, you might be lost because you wouldn't be thinking about variables and stuff. But it's also language agnostic. It really is pseudocode. It is not code written for any specific language. I just happen to do this here in JavaScript, rather try somewhere else. Like I've played using some of these same instructions in like Swift UI, and it understands them, not as well as JavaScript, but pretty good. So you can then proceed here. We create a submit button, and then this was the real logic. How do I get this thing to actually do the thing it's supposed to do? So I say, hey, I have a function called 5 check letters, check each user input. If the letter 1, and I use case 1, case 2, case 3, and I just explain what it does. Now, if you asked me to sit down to figure out the logic to do that, it would take me time and probably a pen and paper to do that. But I just do what to tell it to do. Like, hey, if the letter's in the secret word, change the input background of that letter to yellow. If the letter is in the word and in the same position as the letter is in the secret word, make the input background of that letter green, etc. So I just gave it those rules to tell it what to do, which if you were trying to tell a game designer how to make this game, that's what you would do. I've seen like some people comment like, yeah, but why do you have to tell it that? I'm like, well, so you end up with the game you want. If you don't tell it that, you can end up with something wildly different. It'd be like, oh, I want a game, but I really want it like this, but I'm not going to tell you. Well, you have to be a little specific. So this was the final result, and we can see here the code that it generated to do all of this, how it creates each input, etc. And so it's end up being 187 lines. So if we try to guess the word, and I have no idea. I'm going to go for the easiest guess. Hey, I got the E right. I won't make you watch me struggle through Wordle, but that's all it took. That's all it took, folks, was just 5 instructions. Now let's break this down a little bit so it's helpful when you want to go create your own applications or use this. I find that numbering things, like going number 1 and then say, this is what this thing does. It's a secret word. Number 2, letter inputs. Number 3, make the uppercase when they're added. Because I noticed when I was typing things in, there'd be lowercase, and that was purely a cosmetic thing. 4, submit button. 5, check letters. Sometimes you have your display and then your logic. It depends upon the application where you want to put your UI and where you want to put your logic. You have to figure out kind of where it makes sense. I figured that since I'll create the secret word at the top, so it'll have that. It'll save it as a variable. Then I'll just define my UI, and then I'll have a submit button, and I can decide what the submit button does later because it'll probably know to attach something to listener to it. And then 5, check letters. This is the logic. Check each user input, etc. So this is the logic that figures out what to do. And Codex is pretty smart. It often figures out like what you want to do, but I'm like, hey, if I match the secret word, say you win, etc. Okay. So that was a great strength. This was fun. I'm like, I wonder if I could do the matrix rain effect. I'm like, how hard would it be to do that? So I was trying different things. And I literally wrote matrix rain, create a canvas, create a matrix rain effect with letters, and it did it. It obviously learned from somebody else how to do this. So I take no credit for figuring out some clever word inputs to get it to do that. All you had to do is just say, create a matrix rain effect with letters. And I think we could probably go over to our, let's clear this. Let's see if we do that. Oops, let's go. See if it generates the same code here. But again, if you go, my website's andrewmayne.com, MAYNE.com. andrewmayne.com, and then click on blog, and you can see those examples if you want to play with them. All the code bins are there, and on the blog post, you can see these things and try them. So let's see if it works. And there we go. Just like that. That was taking that example I gave there, so clearly it understood how to do that. So then I'm like, okay, let's try something different. I tried to make a tic-tac-toe game, and it's funny because the logic, it was harder for me to make this than it was to make my Wordle clone. There's probably much easier ways to do this, but I had to figure out like the logic, and it's kind of a tic-tac-toe game. If we take a look here, I put instructions up there. I wrote this. This is my cheat that I added this instruction part, but the game itself, like grid wall, that still works. So you start off, it does a color, and then if I do that, it's got a color. Let me go block it, and then player wins. I can do new game, and that was also, I added like the new game state, and then to that, and then hey, I win again. It's not a very smart player at tic-tac-toe. If you want to make a better tic-tac-toe game, you could actually probably create a logic. There's actually ways you can reduce the inputs to some sort of algorithmical functions, and it may even know those. But that was creating that, okay? The game that was really challenging was trying to figure out, was I wanted to do a vampire hunter game. I wanted to come up with something completely different. And this was one where you're trying to basically find all the coffins where Dracula might be living in a graveyard before you find Dracula. And if you find, Dracula gets you, you die. So the code is pretty simple, but it took me a while to figure out. And here's the thing too, I should add this too. I know nothing about game design. I know next to nothing about game design. Somebody who understands game design and game libraries, who spent more than 5 minutes just looking online and stuff, is going to probably do way better than I am at creating stuff. And that's what's exciting for me to be here talking to all of you, is knowing there are people who know a lot more about the things we want to do than I do, and who are going to probably like, no, just phrase it like this, or just say it like that, and you can do that. So anyhow, I used the array function again. I created an array and said, hey, there's the sirens in the background. All right, folks, I'm getting arrested. Sorry, I have to cut this short. No, not me. We're good. Okay, so I told it to create an array and basically said, I need 26 X's, 2 Draculas, 5 coffins, 3 crosses, shuffle the graveyard array and print it to the console. So you want it each time you do it. Why do I say print it to the console? Because when I'm testing this, remember, I'm doing a 0 shot. All of this is 0 shot. It's all taking just that instruction. I'm not doing this, letting it generate code, then adding game function, because my goal was to be able to copy paste this into, my game, little maker tool right there, and have it just spit it out. And I wanted it to say, if I give it instructions, and I have no feedback other than the thing working or not. So I had to add all those little rules and stuff, and then I had to create a tile. It was tricky because when you see the game itself, each one of these tiles, if I click on a tile, it has to remember its state. And it's like, okay, there's no vampire there. There's no coffin there. No vampire, no coffin. So it has to keep, I found a vampire. I just lost. Okay, sorry. I have to end this now. I'm dead. But seriously though, figuring out like how to keep that state, because it has to know if it uncovers this, and it has to make sure there aren't more vampires than, there should be, and there's a coffin, but it's too late. So that was a challenge. But like I said, somebody who knows more than I. So I was, okay, it knows how to build things like arrays. If it knows how to build arrays, one of the things I did, I don't think I put it in here, is I said, could I build a tile map where it could have a maze and always have an entrance and an exit? Could I do that? And to do that, basically I had to describe it, and it figured out mathematically, like, okay, start generating zeros and ones, and then know that you've got to create a way out or whatever. And it's amazing to see how it solves some of these problems, which means that probably somebody else solved that problem for a while ago, or it's inferring a solution between things. But I used it to create tile maps that were just saying like creating maze paths. I did that, and I'm like, it'd be really fun. Let's go use this with a 3D library. Could I put this with the 3D library? And one of my favorite ones to play with is A-Frame, which is built on top of 3.js. So I went in and I said, okay, I'm going to give it this, which actually is generated by Codex. I can have Codex basically create the top of this to say this. And then I gave it a floor map that was created by the model that was created by Codex, and you could do a generator, but I said I gave it a floor map that had been generated by this that I knew that it created one of an internet exit. That's all I gave it to it, and it was able to generate the rest. It generated everything. Actually, yeah, I forgot what the instructions, but like I basically said, these are the instructions, and then I let it write the JavaScript that came after that, and you're like, oh, Andrew, there's nothing there. It didn't generate anything. I'm like, oh, but wait, let's zoom down because I didn't play with the camera setting. Reset that again. I assure you, it's there. Let me see if I can twist this here. The map it's stunning and amazing when you see it. Try that one more time. I didn't add it. There we go. Hey, it's real. He's okay. He's not a liar, folks. I didn't do anything to reset the camera position. I just literally just let it do that because I didn't want to touch the code. I just wanted to say, here's your start state, finish it. So it generated, I gave it those instructions here. This is the instructions I gave it. And then it generated all the rest. And then it figured out how to extrude this into a wall. So think about this. This is an entire 3D level created by natural language. We just told it what I wanted in the first state to get that original map. I just said, create a tile map where there's always a way out, generate a tile map. And then this case, I just copy pasted into here and said, do this. I guess if I had patience, I would have just gone through and just created a function like I did for the other functions to create that. But I just was curious to see, could I give it that and have it extrude that into this? And it did that. It built that. And you could build other things there, but we're navigating through an entire environment completely generated by natural language and an AI. And so that to me was like really fun and very cool. Image manipulation, I just found out that out of the box, I could say add a canvas, add an upload button, do a file select. And so it will do that. A painting app, it was able to make a painting app just by telling it to add a canvas and create a paint box and select your paint. Again, this is probably not going to replace the painting app you presently use, but this was made in a couple of minutes entirely through natural language. So I go through here some of the lessons learned. Generally speaking, putting the logic first, number your instructions, create functions to make things, retry your prompt, set your temperature a little higher. Sometimes it comes up with better solutions than before. Like GPT-3, it's temperature sensitive, so that will affect the output. So again, Andrew Mayne blog is the site. If you just go to andrewmayne.com, you can click through there. Questions? Perfect. Good. That was sparklingly clear.
All right. We have loads of questions. Thank you very much for your talk, for the presentation. It has been amazing. And yeah, we can start with the first question coming from Tom. Any idea when new Codex and GPT-4 models are coming out?
No. We are constantly iterating. We just released, if you take a look, we just did an update to our GPT-3 models, and we added functions like fill in the middle, which is great with Codex too. So literally, instead of saying start here, complete, you can go here, have your code here and your code here, and say add something to the middle here. As exciting as those other ideas could be, just the potential of being able to rewrite individual things, and it doesn't just follow the thing up here and paste what came before. It works from both directions to give you that response. So I would say take a look at some of those functions. Edit is great because you can tell it like take this. So one of the things, there's building power models to be more powerful, but going laterally to give them this capability. So we're always trying new things.
Then we have another question from Tom. Given how powerful the first version of Codex is, what do you think when we will reach artificial general intelligence?
I don't know. I don't know that deep learning, the approach that we're doing may not take us there. I think it will, but I don't know. And so here's the thing, though. On the path, I'm excited about AGI because I look at we live in a world where the future is distributed unequally, to quote, I think, William Gibson. And what I mean by that is, I live in California, I have paved roads, I have access to food, I have access to a lot of great things. other people in the world have uneven access to that, not even regular electrical power, whatever, food scarcity, stuff like that. There are a lot of these problems that maybe we don't even need, smart systems will eventually help us solve. And I want AGI to sort of help us solve how to do these things. But we might be able to solve a lot of these on the way to there with other things. Ideally, we'd come together and just do the best things. But if we have systems and technologies and things like this and help us there. So my fear of AGI is like everybody else, is like the unknown, what happens to reach AGI. But maybe really cool things we develop along the way could give us a lot of the benefits that we want from it. And we're seeing that already. I mean, I don't have the latest statistics. The amount of code that is being generated now in VS Code using the Copilot plugin, which is based on Codex, is phenomenal. And we're seeing this fast uptake of people using smart systems to help them problem solve. So don't know when, but man, it's already getting exciting seeing what's happening.
There's a lot to look forward to in the future. Then we have another question. How can Codex handle cases of deprecation? Will I just receive outdated code in the future, or is Codex constantly fine-tuned?
We're always trying to improve it, and actually we're experimenting with letting people fine-tune it on their own code libraries, because that's another option we want to see about making available. Whether or not that's, we'll see what the stage of that. But yeah, we're always trying to improve it, and that's the thing, is it's you don't want it to use, to miss the latest updates to it. And so to make this thing useful, we have to do that. We have to keep it up to date.
Mm-hmm. And while you were giving the text input to Codex, you were using terminology from IT. And for example, if somebody who doesn't have a background in IT wants to write a program, then they need to learn to know these words like function, input, output, width, pixels. And one question that we got is, have you tried letting GPT-3 write the input for Codex to make it even easier?
That has been something I've played with a little bit to do that. Here's the challenge though, okay? And I use pseudocode, and functions and things like functions are universal to all programming languages, right? For the most part. And that's the thing, or they all have something like a function. The further away you get, and you might get to the point, is like your Codex is a model, but it's not a super, super smart and wise model. And so you want to be careful when things fill in the blanks for you that you don't know. There's the gaps of somebody not knowing what they're doing. And to give you an example of, I'm going to name somebody, I won't name names, but they're probably standing in this room right before you right now, who played with an early version of Codex and built a thing where they're like, I'll use this thing to design some HTML, built their own interface and said like, make the background blue, and watch their entire interface and everything turn blue because they forgot to put that into a sandbox. Not naming names. And that's the thing you want to be careful of, is to say, like, at this stage, non-coders coding, not that like, they're going to actually create, giant robots that are going to start stomping through cities, but it is the sort of thing where at this stage, it's helpful to understand the basics of code before you create code. But eventually we'll get to things where the goal is eventually, like, I want to build a system that does this, and the system knows, oh yeah, this is a good idea. No, this is a bad idea.
Yep.
Like, instead of, I just erase my hard drive.
Before we dive deeper into the next questions, make sure to write the questions in channel number 2. That is workshops and talks. And for now, we have another question coming up. Will instructive, i.e. technical writing, be the next coding?
Sorry, it just got, your speech broke up just a little bit there. Could you repeat the question for me?
Will instructive writing be the next coding, the new way of coding?
Oh, yeah, no, it's a great question. So I got my start, I formed Magic, but I also started a little publishing company where I would create magic tricks and effects. And so I'd write books and I'd make DVDs. And in doing that, I had to teach people stuff. And in doing that, I had to learn how to break things down step by step. What's the minimal, what steps, how small do I have to get somebody else who's intelligent, who understands the rudimentary things, maybe about magic, to be able to replicate the thing I'm trying to teach. And so that's always fascinating to me, is how much do you break a thing down? I was reading a book. I'm into memory, and I was reading a memory book for kids the other day, and it really wasn't good because they didn't understand what level you have to explain things to a kid. And the same thing with here is that we all are going to want to become better teachers or instructors, and because you need to be specific. So I think that kind of thinking, that logical thinking, is super helpful. That's like the difference between when you try to follow a recipe that somebody had empathy towards you and understood that you're going to be maybe confused about stuff versus somebody who's not, who's like, here are 7 things, do this. And you're like, I don't even know what this term means. Like I don't cook much. And so when I'll read some of these things, like, how would I know what, this way to prepare butter means or something. So you have to think out what level, but yes, I think it's a great key to being a logical thinker is to break things down. And then to have the thing called theory of mind, the understanding of how the receiver sees things, in this case, how the machine sees it.
Mm-hmm. And as a question, we received a question from Sid is, my friend has been using Codex at his work. At the moment, OpenAI has a limit of 2048 tokens or approximately 500 words. Are you looking to expand this limit in the near future? For instance, if we need to make a prediction on a 1,000-word essay.
So our newest models, which we're beta testing right now, we've doubled that. The newest code models have doubled that. And that's how everything I showed you, by the way, the apps I made, we're using the latest model that we have available for our users in the playground like that. So, and that's doubling that was phenomenal because then I wasn't running against the limit. And that's a goal, is to try to keep making those bigger, a bigger context window. When I first tried GPT-3, I'm like, I want to do this. I want to write books. I want to write this. And like, slow down, it's 2,000 tokens. Work within that. And then, but working in that space was great. But also I think that too is, I'll throw this out there as food for thought, is Codex is a system trained on programming languages designed by people with different ideas on how to solve problems that were human readable and designed around the way we think, or a way different we try to solve things. All of them get compiled down into machine code, and in the future it may literally go from natural language to machine code. Let's cut out the programming language and let it decide the best way in between. To me, that's a fascinating thing to think about, is that some of these paradigms we're used to, and it might mean, the length of they may not matter because it might create just a bunch, 1,000 little discrete files to solve a thing, et cetera. But bigger context is helpful.
Yeah. And you have showed us 5 different small apps or examples from Codex. What is the most complex project ever built by Codex that you have seen or done?
There's a lot of things, but what the Copilot tool, which if you have VS Code, you get access to Copilot. Copilot as an assistant has been, I think, a phenomenal use of both the Codex engine and clever programming to figure out how to solve things and do stuff. So I've been very impressed by that. Internally, I see stuff all the time that this just blows my mind. But I would say that like the thing that people's actively using, look at Copilot adoption. You can go do a search for like how many users of Copilot or how much code is there, and you tell you that's proof of like really clever programmers with a really clever tool can make something very useful for everybody.
Mm-hmm. And then we have a question coming from Hai. How can we avoid infringing copyrights when using Codex?
Like any other example of using sample code or whatever from GitHub, is pay attention to where it comes from. We try to do a good job to make sure that it's not infringing code, but you want to double check. But it's the same as if you see a code sample or suggestion you find in Substack or something else, is use the same sort of, due diligence you would for that.
Mm-hmm. And then we have another question coming from Hai. Do you think generative models will fundamentally change the way we create digital artifacts in the future, shifting from manual writing to designing or chaining prompts?
I think that it opens up an entire category for that, if I understand the question correctly. A lot of times, you think about like the average book, nonfiction book, is something like 300 words long. 300 pages, right? That'd be wonderful. 300 pages long, average like nonfiction books. Why is that? Well, the reason has to do more with the publishing industry and how they justify the cost of, let's say, a hardcover book, which is $24. But the information that I need out of that book, or the information that I need from it, maybe what I really want is something that adapted to what I need. And so when somebody's writing this or creating this, instead of writing just text, if you're creating a mini model or creating a mini information system that could maybe be read linearly, but could be done non-linear, et cetera. And I don't know if that quite addresses what with the question there, but to me, the idea is that, yeah, I think there's going to be a sort of a way of writing or creating information and putting it there that for when other people want to consume it, that these models could affect. And that may be a completely different question that I answered than the one that was asked. But
we have seen the strong points of Codex, and now we have a question from Tej coming. What is, in your opinion, the weakness of Codex? Or what can be improved in the future?
One is making sure that it stays up to date. Making sure that it stays up to date is super. You want to be critical about that. Giving people a sense of security that they're comfortable with the code that it generates, that you feel that it's usable, reliable, that it's going to be safe code, is making sure that we're constantly working on this, but we're never going to have a point like, don't worry, folks, everything's solved. That's when you panic. Constantly improving that, improving the number of languages, like it's learning new stuff. Like I was excited to see how well it got Swift UI. Like I like Swift, like I love using like Flutter and Dart, which those of you who don't know are great, languages. Dart is a great language and Flutter is a great environment for working on Android and iOS. And then Swift UI, the things I liked about Dart, Swift UI had. So seeing that develop was great. So, it's weaknesses are going to be just making and improving its quality in other languages, increasing the length, understanding what you want to do more specifically.
And do you think that for the future of Codex, or currently, because it works also with Python, and there are a lot of libraries for Python that incorporate AI models or training of models, and do you think that one day we can use Codex to develop AI models and train them?
Well, I think you can do it right now. I mean, you could take like, it knows the library, let's say like TensorFlow.js, which is a JavaScript library. You could go into TensorFlow.js. You could have Codex generate a very simple learning algorithm system from feedback. You could have it build things like that. So you could build simple things right now with it. Trying to get into more complex things, yeah, it's just a matter of it learning that and understanding that. If you take a look at our one of our papers we did recently at OpenAI is trying to get into things that we learned from building Codex models. The thing that surprised with Codex was it was ability to do a lot of logical problem solving. Problems that GPT-3 couldn't do, a version of Codex could actually solve logically. And then we've also moved towards systems like we have systems that can solve like math Olympiad problems. We have a paper that we put out about grade school math, like trying to do like grade school math and math word problems, et cetera. And what's useful about that is that when you want to start building models to help you build more complex models, you got to be thinking more complex than just addition and subtraction. You got to start thinking about what a tensor really does. What does matrix multiplication do? How do these things really work? And so that's, if you look at our blog posts, you'll see there's a lot of things going towards the directions of being able to build systems that might help with that.
Mm-hmm. All right, then we have our next question coming from Robin. Is the output of Codex filtered? Can it be used to write malicious software?
The answer is we do put in methods to try to limit that, but no, yes, you could use it to write. I mean, what is malicious software? Like if I create something that's just going to write zeros to your hard drive, maybe that's a thing I want to do to clean my hard drive and is a useful application. But if I build a thing that writes zeros to my hard drive and then I wrap it in a .exe file and I mail it to you and I say, hey, help me, here's the thing to add more space to your hard drive. And you're like, cool, this is great. And then it erases your hard drive. Well, I told you what it's going to do. It did the thing it was supposed to do, but that's pretty malicious. So you're always going to have situations like that. But the exciting thing about that is that you can also train code models to recognize malicious software. One of the early examples that was cool that I remember, like the Fast AI course, because they point out as somebody took that course, trained an image recognizer to recognize viruses, because viruses, like the way they were stored in data, had a certain pattern. And you think about using these tools to prevent this from happening. So Codex or technologies like it might create the possibility of saying, hey, I'm going to train it on a bunch of these different examples. And a lot of the hacks that you look at that have been some of these major exploits, a number of them weren't very sophisticated. They were known things. There were known things out there. So you could train a model that could recognize these things and then say, hey, wait a second. I don't think this should be sending all this data to this mysterious .ru domain. So.
Right. And now maybe we can shift our talk to towards DALL-E 2. And
okay.
We have a question that is, what is your favorite thing that has been generated by DALL-E 2 that kind of surprised you?
I mean, my personal favorite, there was a function that was, I did a thing called basically a space raccoon. I wrote a prompt that was, a raccoon astronaut with the cosmos reflecting on his helmet, dreaming of the stars. And I'll share this image with you if you want to see this, because that was a thing that was obviously unbiased because I made it. But let me pull this up here. You get these images that all of a sudden just sort of make you stop and go, wow, this is really something that feels special, feels unique. And let me add. So this was the space raccoon, right? And that was neat because it didn't feel like a computer image. It didn't feel like something that a machine made. This felt like something somebody who loves space and art and whatever would create. And in a sense, it did, because it learned from a lot of examples and learned about that. I would say from a technical point of view, I'd go like, it's not the most impressive technical demonstration, because I know that that model has looked at, hundreds of thousands of images of sad puppy eyes and knows how to make those eyes and make that, but it still feels, wistful when you look at that. But there are a lot of examples of like technical things where it did really complex stuff, but you see it's got the reflections on the glass, reflections on the helmet, and the same as reflections on the eyes. They feel real. It feels really neat. And this was a thing that, as you see, like it had over 3,000 likes, and a number of people were commenting saying that, hey, like I was skeptical about AI. Now I have a different sort of take on it, and that's good. But it's also like, I encourage skepticism of AI. Cynicism's not helpful, but I encourage skepticism of AI, because we need to be watching each step along the way and asking ourselves, is this going in the direction we wanted? But anyhow, that was for me like kind of a really neat moment. Was seeing that image created. I showed it to my wife, and she was like, "Oh, it's so adorable. We should put a poster of this up in our thing." And she finds some of the stuff I do at work interesting, but this was the first time she was like really like amazed.
Now, talking still about DALL-E 2, we received a question. Is it possible that we can have a 1-hour access to DALL-E 2 special to Makeathon participants? We can arrange a competition and ask you to choose the winner.
I wish I was in my power, but I would say everybody go sign up for the wait list, because when we start giving access to people on there, literally we're going to go through the wait list, and that's what's going to be there. So don't think like, oh, I'll add myself to the wait list later. Do it now, sooner than better. That would be really cool.
The next Makeathon.
Yeah, and that would be hopefully by the next. I mean, it's up to me, by the next one, just everybody have access to it already.
Right, and maybe one final question before we finish. What do you think these images generated by DALL-E 2, what can they be used for in our society, or what can be DALL-E used for in our day-to-day life?
This is just me speaking my own thoughts on that. Look at what's happened in the last 10 years. The amount of information we have to process has increased tremendously. Remember my demonstration in the very beginning about sharks, and talking about how sharks have kind of small brains and a flood of information from their nervous system, from their eyes, their nose, everything else. And they have to develop these algorithms to handle it efficiently. We developed systems the same way, between Facebook and Twitter and email and text messages, notifications, all the amount of data. If you look at the amount of people trying to communicate and things, sending you information, no human being has ever experienced this in the history of humanity. So what have we done? We have things like emoji now, okay? I use Slack at work. Slack, by my own off the cuff sort of estimate, the majority of communications on Slack is actually email, is actually emojis. It's basically, I said a thing. 20 people provided little emojis to say, indicate a response. I like this. I don't like this. This is cool, encouraging, whatever. But really, these systems have become conduits for using emojis. Memes and GIFs, sort of this interchangeable, but a meme can be a GIF, but not all GIFs are memes, and vice versa. But anyhow, these things have become very effective ways. Like I had a friend of mine, we've had on more than one occasion, some news will break, and we've had this happen where at the same exact time, we send the same GIF to each other, and it goes boop, boop, and it just pops up because we're using this as a way to express ourselves. So we're using imagery now to communicate, because imagery is sort of one of our oldest form of nonverbal communication was to draw pictographs, communicate like this. We understand it. We can do this. Think about a world where when you want to open up a text message to a friend, you just describe a thing, and that image pops up. You're like, hey, you want to go grab pizza, and it's an image of you two eating pizza, or it's a pizza, the most amazing looking pizza ever. Or you want to congratulate somebody, and maybe your secret avatar, like I identify with raccoons, and so maybe my avatar is me as a little raccoon high-fiving somebody else who's like a chipmunk or whatever. We know that's us. Think about the power when we can conjure up any image we want on demand to communicate and express an idea. We'll still have text. Text is never going to go away, our ability to communicate there, but all of a sudden it's like telepathy, but a way you can control. I can take this idea and put it in your head. That's what's exciting to me, is the idea of making it to the point where it just becomes just a second nature to us.
And have you used images generated by DALL-E to train AI models? Have you tested that field to basically generating a data set?
So there's I specifically to a researchers doing that, what the avenues there are, like I don't know. I would say that I know that the danger is if you use images to train a model to do more images, it's kind of like a Xerox effect where you keep making a Xerox copy of a Xerox copy of a Xerox copy. And there can be places where it might be useful, like making really small models and sort of use it as a data set to do that. But the limitation is it's going to be hard to improve the overall, and there probably is an argument to say you probably could, but it's hard to improve the overall quality because you don't know what trade-offs. You have to look at a lot of images to go, oh, it doesn't get this. And read the paper. DALL-E has limitations. There are things that like people are like, oh, it does anything. I'm like, no, I can show you how it doesn't. I can show you examples of things it struggles with, which aren't secret. They're in our paper, and I talk about that. And if you want to improve upon that, then you have to figure out like, okay, how do I have a bigger data set? And also there's the fear, and it's a real fear, is that like, what happens in 5 years from now, 10 years from now, when 99% of all the content on the web is generated by a model? Then it's like, well, it makes it harder to train models because it's just using degraded versions of that.
And we are slowly finishing the end here, but we have one last request, and that is we have our meme challenge for our Makeathon participants where they compete to create the best meme on the topic of AI. And we have a request coming in. Can you use DALL-E to create a meme that's on the topic of AI?
All right, let me go into here and give me a, what do you want? Give me some more to go off of. What would you like? What do you want the text prompt to say?
I don't know. So usually we do jokes around AI.
Okay. All right, and artificial intelligence. Telling jokes in a comedy club. Okay, how about that? Let's try it. And it may not be a good prompt. Normally we'll do this, but let me just go create this behind the scenes just in case it decides to like, my taste on it. Do that. I'll share this in a moment. What's really, by the way, like the thing that really surprised me too with DALL-E was its ability to do things like pixel art, all these other sort of styles, all these other sort of ways of doing that. And the ability to sort of figure out like how to create something, that represents either watercolors or digital. And so I probably should do this digital art. let me do this one more time. I'm going to do a robot telling jokes in a comedy club, so it's less of an abstract thing. We'll do it as digital art. All right, and I'm going to let it render. Create this behind the scenes here. So the way when you see the interface, by the way, for our to use DALL-E, we have a thing called labs, which is where we're going to start letting people test out things like this, because it's very helpful to sort of let people see the input. And for us, is we want to see how people use things. We want to understand a lot. Okay, you ready? This is it generated 10 images. There we go. We got
That's really high quality.
yeah, that's pretty good stuff there. And we could do, again, it has to figure out what it wants to be for a robot. But like we could take this, by the way, if we have a moment, indulge me. I can erase this and say next to an open, a neon. Let's see if it does that. So what it's going to do here is it's going to take this original image and then it's going to see if it can fit in there. I may not have given enough space to do that. And so it's going to go in there, take the existing pixels, use that, and then try to complete it with what I added there with like the neon sign. The challenge would be if it doesn't think that that sign will fit into that space, then you'll see it's not going to put it there. It'll just fill in the rest of it. When you use the tool, by the way, the erase tool, a lot of people I'm like, it's not like Photoshop. Erase as much as you want. So there we go. Oh, did the neon sign. Now you notice, what does DALL-E struggle with? Word. We haven't even really started to sort of train it yet on how to do to create words, and it's to my estimation that's going to be a very solvable problem. But we're kind of nailed down the images first. So there you go. This is exciting. It's exciting time to see what everybody's working on this, and you see the more brains, the more people solving things, the faster. We're in an acceleration curve, folks. Like things are accelerating fast. A year ago, people weren't asking about, and there wasn't somebody working. Well, maybe you were working on your master's thesis back then about that, but that's how fast it's moving.
All right, now we're a bit over time. Thank you very much, Andrew Mayne. It has been an amazing workshop. Thank you, participants, for all of your questions. And as we have mentioned, you will have access keys to both the GPT-3 and Codex, and we're excited to see what you will do with these models. And going next on our agenda, we have the pub quiz at 8 o'clock. So that's it. That is in 20 minutes. And for this pub, make sure to join GetterTown. You have all of the information, all of the links in Slack. And if you win the pub quiz, you win 100 euros. So make sure to take place in our quiz, which is hosted by and organized by Ollie, one of our team members at the Makeathon department. And till then, have a pleasant break and see you at the pub quiz in 20 minutes. Bye, guys.